Okay, so today we are just going to learn how to simplify radicals. These notes are a little long, but they're super simple once we get through them. So the first thing we need to do is to identify what a radical expression is. So a radical expression is just an expression that contains a radical. Okay, so we can have some of our examples are just the square root of 3 or the square root of 5x, or we can even have the square root of x minus 10. Any of those are considered radical expressions. So a radical expression is simplified when the following statements are true. So we have a radical, the radical has no perfect square factors. No perfect square factors other than 1, because obviously 1 is a perfect square. We also have that the radical contains no fractions. Okay, and the last thing we need to have is that there are no radicals in the denominator of a fraction. Okay, so if we've got all of these true, that means that our expression is simplified. So we can use a couple of different properties. Our first property is going to be the multiplication property. So if we have for a number a is greater than or equal to 0 and a number b is greater than or equal to 0, if we have the square root of ab, that's going to equal the square root of a times the square root of b. So we can just separate those square roots. Okay, so an example of this, we have the square root of 48. So that's going to equal, we can factor that a little bit and say that that's just the square root of 16 times the square root of 3. Since we know the square root of 16 is 4, that just means that we've got 4 square roots of 3. Okay, so that's basically all we're doing. So when we're using the multiplication property, we're just removing the perfect square factors from the radicand, which is the number inside of the radical. So if we go to the first page, what we have is we want this simplified form of the square root of 160. So what we can do is we can factor this out all together. So I'm going to use a factor tree. So this is just an easier way to look at it. So we can divide this number, this 160, by 2. When we divide 160 by 2, we're left with 80. So if we split 80 up, we can divide that by 2 as well. That leaves us with 40. We can divide 40 by 2, which leaves us with 20. We can divide 20 by 2, which leaves us with 10. And we can divide 10 into 2 and 5, right? Okay, so we're going to find the pairs of numbers that we have. So we have a pair of 2s, and we have another pair of 2s. So what we're going to do is we're going to take 1, 2 from this pair, and 1, 2 from this pair. So we're going to have 2 times 2 on the outside. Then on the inside, we are still going to be left with this 2 times 5 on the inside. So when we do that, that leaves us with 4 square roots of 10. And that's going to be our answer because we have no perfect squares under the radical. Okay. So if you want to go ahead and do the got it problem, go ahead. We're going to have the square root of 72. Okay, so the square root of 72, we're going to factor it out. So we can divide this by 2, and that leaves us with 36. when we take the square, or when we divide 36 out, we can actually divide that out into 2 equals, so that gives us 2 6s. So we're going to take one of these 6s out and put it on the outside, and what we are left with on the inside is just this 2 over here. And that's it, okay? So we can also simplify radical expressions with variables. So if a variable has an even exponent, it's a perfect square. If the variable has an odd exponent, then it's the product of a perfect square and another variable. So if we have n cubed, what that really means is we have n times n times n, okay? So that means that we've got n squared times n. So in this lesson, we're going to assume that all variables in the radicand represent non-negative numbers, just to make it a little easier for us. Okay, so if we go to this first one, we've got our 54. So we're going to have a square root of 54. And since this is odd, we're actually going to have n to the 6th times n. Okay, so that's just a way to expand it. And we're going to do that same thing that we did on the last page with our 54. We're going to separate it out so we can divide 54 by 2. That leaves us with 2 and 27. If we do it again, we can't divide this 27 by 2, but we can divide it by 3. So we're going to have 3 and 9. And if we divide that out, that's going to give us 3 and 3. So we only have one pair of numbers, which is this 3. So we're going to pull 3 on the outside. We're also going to pull out however many 6s we can. So if we have, or however many n's we can. So we've got n times n times n times n times n times n. Okay, so you're going to have 1, 2, 3 n's on the outside, n to the 3rd, and left in the square root. So we got rid of this n to the 6th. We're left with an n on the inside, and we're also left with this 2 times 3, which is 6n. So that should be our answer right there. Okay, let's go ahead and work on the got it problem. Okay, so for this problem, we've got negative m on the outside, and we've got 80 m to the 8th times m. So we're going to go ahead and factor that 80 out. So we've got 2 times 40, just 2 times 20, just 2 times 10, just 2 times 5. Okay, so our pairs of numbers, we've got these 2's right here, and we're left with this 5 on the inside. So we're going to pull 2 out of here and a 2 out of here. So that's going to give us negative m times 2 times 2 times. We have 8 m's, so 1, 2, 3, 4, 5, 6, 7, 8. Got 1, 2, 3, 4 pairs of m's, so we're going to have m to the 4th on the outside, and that leaves us with 5m on the inside. So when we multiply this negative m times m to the 4th, that leaves us with m to the 5th, and negative 2 times 2 gives us that negative 4 on the outside, and we are still left with this 5m on the inside. Okay? So our next page, what we're going to do is we're going to multiply our radicals together, and then we're going to simplify them. So when we multiply radicals, we can multiply the outsides together, and then we can multiply the insides together. So what we're going to do is we're going to multiply this 2 times 3, which gives us 6. And on the inside, we have 7 times 14, which gives us 98. And we have t times t squared. So I'm just going to write that again. T squared times t. Okay, so we're going to take this 98 and factor it out. So if we have 98 divided by 2, that gives us 2 and 49. And if we factor 49, we've got 7 and 7. So we're going to have a 7 on the outside times 6. And then if we just take one t out, because we've got t times t, so that's a pair, we take that out, we are left with on the inside 2t. Okay, so we've got 7 times 6, which gives us 42. There's a t on the outside, and we've got 2t on the inside. Okay. So go ahead and start working on the got it problems. If we do this, we're going to have 3 square root of 108. So if we factor 108 out, gives us 2 and 54, 2 and 27, 3 and 9, 3 and 3. So we've got 2 and 3. So we're going to have 3 times 2 times 3. And inside the square root, we've got another 3. So if we do 3 times 2, that gives us 6, times 3 is 18. So we're going to have 18 square roots of 3. Perfect. Going down to the next one. In our radical, we're going to have 18 a to the 4th. So if we do that, we're going to have 18, which is 2 times 9, which gives us 3 and 3. So we're going to have 3 a squared, because if we've got a times a times a times a. Okay, and on the inside, we are left with this 2 right here. So we should have 3a squared square root of 2. Okay, and our last one, we've got 21 square root of 100 x to the 6th. We know 100 is a perfect square because it goes to 10 and 10. So we're going to have 21 times 10 times, we have 1, 2, 3, 4, 5, 6. So we've got 3 pairs of x's, so we're going to have x cubed. And we have nothing left on the inside of that radical. Okay, so that's going to leave us with 210x cubed. Okay.